All right, let's do another common related rates problem, a conical problem or a volume problem. This is very common on the AP exam and just any exam in college that deals with related rates. So, water is drained from an inverted conical tank at a rate of 3 cubic meters per minute. The tank has a height of 12 meters and a radius of 6 meters at the top. How fast is the water level changing when the water is 8 meters deep? So first things first is let's draw this out. So we have a cone, tank, something like that. We have water inside the tank that is leaving from the bottom at a rate of 3 cubic meters per minute. We have the height of the cone tank is 12 meters and the radius is 6 meters at the top. So how fast is the water level changing? So what that means is what is the height, the rate of change of the height of the water as it goes down? So first step we want to do is write down what we know, right? So step one, what is the given, right? So since the water is draining, the volume is going down. So I can write dv dt, the change in volume over the change in time, is equal to -3, right? Negative because it's decreasing. And what I want to find, so step one, we have given, and then also, what we want to find. We want to find, we'll say dh dt at h is equal to 8. All right, so this is 0, this is 12. When it's 8, so we'll say 8 is about there. What is the rate of change of the height in terms of time? All right, so let's go on. Step 2, let's write the formula of the volume of the cone since we'll be dealing with that. So I'm just going to say formula time. So we have the volume of a cone is equal to V is equal to 1/3 pi r squared times height. But here's an issue. This formula has both radius and height, and both of them change as the water level changes, right? So as it decreases, the radius goes down and the height goes down, right? So before we differentiate, we need to rewrite everything in terms of just one variable to make it simple, right? So let's go to step 3. So we need to try to find or rewrite in terms of one variable. So to do this, let's do this by using similar triangles. So the full cone has a radius of 6 and a height of 12. So I can write radius over h is equal to 6 over 12, which is just 1/2. And now let's rewrite this in terms of r. So we have r is equal to 1/2 h, right? H over 2. So now we can go back to our formula time. This is also called your constraint formula, as I used in my last video. So let's rewrite this constraint formula with the given in terms of one variable. So step 4, substitute into constraint. So that'll give us, so that is V is equal to 1/3 pi r squared times h uh, is equal to 1/3 pi h over 2 times h over 2 squared, which can be rewritten as, I'm going to write it over here, h over 2 squared, this becomes h squared over 4. So this becomes 1/3 pi h squared over 4 times h. Let's multiply, that out, simplify it. We get 1/12, right? Multiply the 1/4 out times pi times h cubed. Now, the volume is only written in terms of only h, which is exactly what we want because this allows us to differentiate without having to use any complex um, differentiation techniques such as implicit differentiation. Keeps it very simple. So here we have our formula. Volume is equal to 1/12 pi h cubed. So step 5 is to differentiate with respect to time. And again, all this means is that everything is going to be over dt. So let's differentiate both sides. We get dv dt is equal to 1/12 pi times 3h squared. So this is equal to 1/4 pi h squared dh dt. All right, now let's plug in our known values. So we know that dv dt is equal to -3, and we know that h is equal to 8, as seen here. And that is another way to determine what variable you want to substitute for in this section right here. So we know that we have an h, so we want to rewrite and get rid of the r so that the formula we use is in terms of what we have. All right. So now that we have dv dt is -3 and h is 8, let's rewrite this. So we have -3 is equal to 1/4 pi times 8 squared dh dt. Let's simplify this 8 squared. This becomes 64. Sorry, that's a pi times dh dt. And dh dt is what we want to solve for. So let's rewrite in terms of dh dt. So we have dh dt is equal to -3 over 16 pi. And that is our final answer. So the negative sign makes sense because the water level is falling, it is decreasing. And yeah, there you go. So see how we didn't even need to use the radius given? That is very common in related rates and optimization problems. Sometimes they give you more information than you need to confuse you, but don't worry. Take these steps and you should be able to solve any type of water tank, volume problems in the future.